acid-base reactions. So before we can talk about how acids and bases react, we need to know what they are. Now, there are several definitions for acids and bases, but for general chemistry, for this portion, we're going to use the Arrhenius definition. So, a acid, when it dissociates in water, we have nitric acid. Here's an example. It will dissociate to H+, aqueous, and nitrate. So, according to the Arrhenius definition of acids, this generated H+. Technically speaking, H3O+ is what's generated. Remember, aqueous means for this substance to be dissolved in water, but chemists often use the shorthand denoting H+. Okay, water is the medium which dissolves this acid. Bases, according to the Arrhenius definition, when they dissociate in water, generate hydroxide. Notice, so hydroxide, OH-, a proton, H+, H2O. So one of the products when acids and bases react, according to this definition, is water. Okay, so products of an acid-base reaction. Form water and a salt. That is an ionic compound. Whether it's soluble or not, you've got to refer to those solubility rules that you've encountered. But if we have an example, or we have an example here, so if you have nitric acid reacting with sodium hydroxide, form water. Okay. Now this is a little strange how I've written that. Come back to it. Plus the reason I know to write aqueous for sodium nitrate is I remember those solubility rules. Nitrates are always soluble in water, and so are group 1 metals. So I wrote aqueous. So I wrote water, HOH, just to denote that the proton, or this hydrogen atom, came from the acid, and then the hydroxide came from the base, forming water. Then sodium as a cation pairs with the nitrate anion to form the soluble salt. And you have to check and see that the equation is balanced. One sodium, one hydroxide, one proton that came from, in water, that came from the acid, and then one nitrate. There will be more complex examples upcoming, but before we can do acid-base reactions, you have to know what the definitions are and what the products are. how do you write the products for an acid-base reaction? Here, you have nitric acid and barium hydroxide. You've got two acids and things to memorize, acids and bases and things to memorize. You have to recall those. But we know that the products for an acid-base reaction are water and a salt of some sort. But to begin this, you have to know what the charges are for each component of the acid and the base. So, nitrate is one of the polyatomic ions that you have to memorize. The whole nitrate ion has a -1 charge. Protons have a +1 charge. That compound is neutral in that form. The sum of the charges equals 0. Hydroxide, again, is one of the polyatomics that you have to know the charge. It has a -1 charge. But there are two of them. So 2 times -1 is -2. And barium, if you look at the periodic table and find it, you see that it usually forms a +2 charge. In ionic compounds and soluble compounds or bases as well. 2 times -1 is -2, +2. This barium hydroxide is neutral. Now, in an acid-base reaction, these charges do not change. So we have water. One of the products. And then the barium, it's a cation, will pair up with the nitrate, the anion, the opposites attract. However, the charges do not change, so this is still barium 2+, and nitrate is still -1. That doesn't change. So now, that means that this salt, this soluble ionic compound, isn't correct the way that it's written. All ionic compounds have to be neutral. So in order to write that correctly, you have to make sure that the charges cancel each other out. So recall from chapter 2, 2+, we have 2 nitrates, -1, 1 barium cation. That should balance. We double check ourselves. 2+. Nitrate is -1, but there are 2 of them. That sums to 0. So let's rewrite things. Nitric acid. We react with barium hydroxide to yield water. Plus barium nitrate. Not put the phases here, but nitrates are always soluble in water. Okay, so that would be aqueous. But now, that is the correct formula for barium nitrate, but the equation is not balanced. The first step is you make sure your compounds are correct, then you balance your chemical equation. I have one hydrogen. Okay. From the acid, the reactant side, I have one nitrate, one barium, and I have two hydroxides. On the product side, I have one hydrogen from water, one hydroxide, one barium, and two nitrates. So you can see that the equation is not balanced. To balance it, start with something that only appears in one reactant, one product. I'm going to start with nitrate. Hydrogens are out of balance. Balances the hydroxides as well, and that's that equation balanced. This is a 2-to-1 reaction, or titration, or acid-base neutralization. It takes 2 moles of the acid protons to react with 1 mole of the base, because it's dibasic. It's got 2 hydroxides for the reaction to be neutralized, to make water and the salt. So that's the process. Balance, make sure that your chemicals that form are correct. The ionic compound is charge balanced. Then you balance the chemical equation using molar coefficients.